Hi everybody. So in this video we're going to review lesson 9 and focus on our parabolas, our quadratic functions. So let's get started here. So let h of t be a quadratic function that represents the height of an object above the ground t seconds after it was launched. So I'm taking an object and I'm launching it, and eventually gravity is going to take over, right? So if I launch an object, eventually gravity is going to take over. It's kind of going to make this parabolic shape. So it makes sense that that it's going to be some kind of parabola because it's going to launch up and then eventually gravity is going to bring it back down until it hits the ground. So three different but equivalent representations of h of t are shown here. So I have three different but equivalent representations. So this first representation is negative 16t squared plus 64t plus 80. This represents standard form. So that's the standard form representation of this parabola. Why? Because it's ax squared plus bx plus c. It is a polynomial written in standard form. And the only nice thing we get from standard form is the y-intercept. We get the y-intercept is the constant, the 80. So the constant term is the y-intercept. It's the initial height. So in this case, the initial height of the object is 80 feet. So the initial height of the object is 80 feet above the ground. It's starting 80 feet above the ground. 80 feet, let's say that, above the ground. So standard form is boring. It doesn't do a lot for us. It just tells us that initial starting value. It's our y-intercept. What's more interesting over here is factored form. Notice I wrote it as the product of factors. I'm multiplying things together. This is called factored form. Factored form tells us our zeros. Well, what's another word for zero? The roots. What's another word for roots? The x-intercepts. It tells me that where do I cross the x-axis? Those important points of the parabolas, that's related to its factors. So in this case, if we use the zero product property, we get t equals 5 and t equals -1. That's when it equals 0. When does h of t equal 0? When do I equal 0? At 5 and at -1, because I just used the zero product property. What makes that factor 0? 5. 5 minus 5 is 0. -1 plus 1 is 0. So I find my zeros, I find when does it equal 0 by factoring. So if I have standard form, we factor to get to factored form. So what this tells me in terms of the object is this is when the object hits the ground. The object hits the ground. Well, where? At 5, I don't know, let's say seconds. It's 5 seconds. -1 I'm going to reject here. I'm going to actually reject -1 because I can't have negative time. Well, -1 is still a 0, but I'm going to reject it because I can't have that negative time. And then finally, the last form, which we learned about last week. If I go from standard and I complete the square, I get vertex form. Why do we call it vertex form? Well, it tells us the vertex form tells us the vertex. That shouldn't be shocking. We also get the axis of symmetry from doing this. We get the axis of symmetry is hidden in vertex form. How do we get here? We complete the square. We have to complete the square of standard form to get over here to vertex form. And in this case, the vertex, remember the transformations. Opposite, the same. Opposite of the inside, the same as the outside. So the vertex is 2, 144. And I know it's a maximum. This is a maximum because the leading coefficient is negative. Because the leading coefficient is negative. I have a concave down parabola. That highest point is my vertex at 2, 144. So what does this tell me? The object reaches a maximum height. The object that I launched reaches a maximum height of 144 feet at, when did it happen? At 2 seconds. How do I get the axis of symmetry? There it is right there. X equals 2 or t equals 2 is the axis of symmetry. That x value is the axis of symmetry. The x value of the vertex is the axis of symmetry. So notice I got a lot of information just by looking at different representations of this parabola. And now I can make a nice little sketch. I can make a nice sketch of this object being thrown. I know it has a y-intercept of 80. It hits the ground after 5 seconds. 1, 2, 3, 4, 5. So that's when the parabola is going to hit the ground. We'll use the galaxy pen. I hit the ground here. I start here. And I know I have a vertex at 2, 144. 144, we'll say, is up there. At 2, 144. And that's kind of my axis of symmetry. So what other point do I get? This is important. What other point do I get? Well, how far away is 80? It's 2 away. So if I go 2 over, there's another point. So notice 80 was my y-intercept. I go to the axis of symmetry. 1, 2, 1, 2. There's my other point. So here is the object hitting the ground. The object got launched from 80 feet. It went up to 140, and then it hit the ground 2 seconds later. So it got shot up in the air. It flew up. So here's my object. It got shot up in the air, and then it flew back down all the way to 80 feet. And it makes that nice parabola at 5 seconds. So that's how these different representations help us sketch pictures. We have standard form, factored form, and vertex form. I'm going to do one more problem with you, and I'm going to let you guys do some on your own. So consider the function f of x equals x squared plus 12x plus 20. Rewrite this expression in factored form. So I want to rewrite this function in factored form. So I'm going to factor it. How do I factor trinomials? Well, I draw a box, x squared and 20. What multiply? I'm going to ask myself, now you guys missed me saying that. You're going to ask yourself, what multiplies to 20 that adds to 12? Well, 10 and 2. 10 times 2 is 20, and that adds to 12. So my factors are x plus 10, x plus 2. So f of x equals x plus 10 and x plus 2. That's my factored form. I changed it from standard form to factored form. And I'm going to rewrite the vertex by completing the square. So I'm going to start again at standard form. I'm going to start here in standard form, but this time when I make my box, I'm going to rewrite it in vertex form by completing the square. So I'm going to cut my middleman in half. Notice it's a different process than factoring. It's the same box idea, but it's a completely different process of using our tables, using the box. So my magic number, 6 times 6 is 36. 36 is the magic number I need to add in. So f of x equals x squared plus 12x plus 36. Well, I'm not just going to add in 36. I'm also going to subtract 36 to counteract that addition. Otherwise, it's not going to be equivalent. So my final step is now to factor it. What are my factors? Well, it's x plus 6 squared, right? X plus 6 made a square. And then outside I have minus 16. That's a vertex form. So now using these three representations, we can state these key features. What are my x-intercepts? What are my zeros? Well, my zeros come from factored form. They're at negative 10 and negative 2. What is my y-intercept? Well, that comes from standard form. That comes from up here. My y-intercept is at 20. Y equals 20 is my y-intercept. 0, 20 is is kind of that starting point of the parabola on the y-axis. The vertex, guess where that comes from? That comes from vertex form. Where's the vertex here? Well, what shifts happen? I need to go left 6, down 16. Remember, it's opposite the same. Left 6, down 16. So that's my vertex, which tells me my axis of symmetry is x equals negative 6. There's my vertex right there. So it was really quick for me to get kind of a sense of what this parabola looks like by using all that information. So let's graph it now. Well, what are my zeros? Where do I hit the x-axis? At negative 10 and negative 2. So here I am at negative 10, negative 2. I hit the x-axis at those points. Where do I hit the y-axis? I hit the y-axis at 20. So all the way up here at 20, I hit the y-axis. And the vertex is in the middle here at -6, comma, -16. I'm just doing a nice sketch here of this parabola. So my axis of symmetry goes down the middle there, and I can do a flip. 20 to the, how far away is that? Well, that's 6 away. So if I go 6 more, that brings me over here to, this is the 5th point. This is like the hidden point, right? This is 6, a distance of 6. So if I go 6 more, it's at the same height. So that's at -12. It's at -12 there. So my parabola looks like this. My parabola looks like that. Using those 5 key points, I use the y-intercept and his reflection and its reflection. I use my zeros and I use my vertex. That gives me 1, 2, 3, 4, 5 points that makes this parabola and gets me a pretty good idea of what's going on. So part of your problem set this week is to work on question 3 here, which is very similar to question 2. Refer to question 2 to kind of walk you through the process. I want you to factor it. I want you to complete the square. I want you to tell me all this good information here and then sketch me a graph. So that's what I'm having you upload this week. You can do it on paper. You don't need, if you can print this, great. You don't have to print it. You can just show me the steps and show me all this work here. I don't need it perfect. I can figure out what you're doing. Or you can use Cami. You can use whatever you want to use, but I need to see the work, not just the answers. I need to see the work and the answers for this question here. So number 3 is what I'm having you submit on the problem set before you do those multiple choice questions. That's all I've got for you this week, guys. Stay well and work hard for me. Work hard this week.